So I don't know why Gina wrote this as the triangle proportionality theorem. Yeah, we were back to Gina, you can tell. Here, Gina, we want to do? I don't know why she the theorem. I don't know if she was like feeling. Yeah, I don't know. A lot of people call this the side splitter theorem. I don't know if that's because it sounded too Halloween-like. It sounded violent. Side splitter. Yeah. Smackdown. So, but the side splitter theorem seems to be a little bit more accurate. A little bit more, or not accurate necessarily, but more common. I mean, triangle proportionality theorem, I've heard that too, but side splitter I've heard more. So I'm just gonna highlight that so that when I look at my notes, my eye is drawn to that and I memorize that name first. All right. So here is the theorem in all its wordy glory. If a line is parallel to one side of a triangle, so here's the line DE, is parallel to one side of the triangle, that's AC, and intersects the other two sides, then it divides the sides into segments of proportional lengths. So we're saying if DE is parallel to AC, then this side over this side is proportional to this side over this side. So BD, it doesn't matter how you write it, but BD over DA is proportional to BE over EC. So side splitter theorem because we split the sides and we said they were proportional to each other. So let me go ahead and zoom in on that so you can read that better. Is that easier to read? And then the converse is true as well, which means if you look and you can see that the split sides are proportional, so if BD over DA is proportional to BE over EC, if you see the sides are proportional, then that means that you can conclude that DE is parallel to AC. So you can go back and forth like that. Isn't that fun? How fun. What a fun day of math we're about to have. So fun. So fun. How fun. All right. We good? We good? We need to see the picture again? There's the picture? We got it all? Yes. Are all my notebook people having a good time today? That's fine. All right, here's number 1. So we're doing the regular side splitter theorem because they said they're starting us off with, yep, the lines are parallel. So we said, okay, this is the regular version, not the converse, this is just regular. And so we're going to say, all right, the sides are proportional. Let's use that to solve for x. So I'm going to say 14 over 12. It doesn't matter which side I do first. I could have done 12 over 14, or I could have started with the other side. It doesn't really matter. So 14 over 12, then I'm going to be consistent. Since I did left over right here, I'm going to do left over right here. Equals x over 15 for this one. And then anytime we have a fraction equals a fraction, what do? Cross multiply. All right, wasn't that fun? Whew, that was fun. That was fun. Go ahead and circle number 2. I'm going to leave that one for you guys. If you don't have to do it right now, you can do it later. All right, let's look at number 3. So go ahead and write down number 3. If you are a notebook person, just leave room for number 2 so you can do it later. And then you can look on the website on Canvas to get a picture of number 2 to do. All right, so what should we do with number 3 proportion? Yeah. Yeah, so we'll do okay. Here we go. All right, so now what should we do? Okay, 45 over 10. So we're doing right over left, or we could say bottom over top equals 36 over x, and then we're going to go ahead and cross multiply. All right, go ahead and circle 4. You guys can do 4 later. Gina is so good at giving us all the examples. Got it. Do this. Don't need all these examples, Gina. Oh, here we go. Okay. All right, what should I do with this one? We're going to have some distribution in the problem. But before I distribute, what should I do? So top over bottom equals marvelous. Okay. So when we do this one, our cross multiplication is going to use some distribution. Okay, so we'll distribute that 25x plus, how much is 7/4? Okay, so 175. Okay, how much is $4.50 minus $1.75? Marvelous. So, how many quarters are in $2.75? That was quick. 4, 4, 3. 11. We did that whole problem in quarters. Wasn't that fun? You just did it in the calculator? You just didn't think in terms of quarters? Anytime it's in 25s, I think in terms of quarters. You don't like quarters?
I don't like quarters because I smell bad. What? They smell like gross metal in people's hands.
Okay. So people who are not white say that people who are white smell like pennies when they get wet.
Okay.
I'm just saying.
Wait, you mean like shower
Or rain.
Oh, okay.
Google it. It's a thing.
Wait.
And Karina, are you laughing? And what do white people smell like when they're wet? Ask her. It makes me self-conscious.
What do white people smell like when they get wet?
Sense. That. We're a room full of mostly white people. We would smell like a bag of wet change. I'm sorry to the non-white people in the room who don't want to smell like wet change with us. You're part of the group. All right, let's move on. You learned something today. All right, so yes, you're doing number 6. Did Siri confirm it for you?
White people smell like wet dog and bologna.
That's good. That's good. We could make a whole list. Yes.
A lot of wet dogs.
Well, you don't think you're not gonna think yourself. Although I did see a TikTok where a guy like licked himself and smelled it, and he was like, "I do smell like loose change."
No, it smells like there.
All right, let's move on. All right, now this one did not tell us that the lines are parallel. This one gave us 2 sides, and they are asking us if the lines are parallel. So this one is using the converse of the side splitter theorem because they want to know if the 2 lines are parallel or not. So we're going to go ahead and set this up. This should maybe bring back some memories of proving if 2 triangles are similar. Do you guys remember when we did that? We set up the proportions. Do you guys remember? You don't want to bring back those memories? Okay, those were not bad. I mean, we did proofs around those times, but this is going to be easier. Because remember, when we set up their proportion, all we have to do is compare the decimals. So we're going to do 11 divided by 15.4, and we're going to do 10 divided by 14, and then we're going to say what? What's our conclusion? They are parallel. So determine if MN is parallel to JL, and we're going to say MN parallel to JL. Yes. You could cross multiply and then make sure it equals the same thing. That works. Yeah. So the reason I did what I did is because that is consistent with what we learned before. I just want to be consistent. So yes, you can cross multiply, but you can also do this, and this is consistent with what we learned in a preview. All right, let's do number 8. So what should I do? (18/5) equals 15/4. So you can do the cross multiply method, or you can check the decimals. So 18/5, 15/4. So what is my conclusion? Not parallel. Not parallel. All right, go ahead and circle 9. You're going to do 9. All right. Now, for the next one, this is an extension of the side splitter theorem. This, is truly just parallel lines and then proportionality, because you're not really splitting sides, you're splitting lines. We could call it the line splitter theorem, I guess. But this one is very similar. It says if, and this time we're not talking about a line segment, we're talking about a line that keeps going. So they actually put arrows on both ends of this. So if line AB is parallel to line CD, and that is parallel to line EF, so we have to have 3 parallel lines for this to work. If they're all parallel, then AC over CE and BD over DF are proportional. So it's the same, it's the exact same thing. It's just instead of using a triangle, you are using 3 sets, or a set of 3, a set of 3 parallel lines to create the same idea. Okay? So not a triangle, but this shape instead. Same idea. Like a triangle, but more like a trapezoid, where all the lines continue. Okay, so let's go ahead. Did you guys have enough time to write it down? Poor notebook paper people. It is a struggle for the notebook paper people.
Put your phone up if you like math. Oh my God.
2 thumbs up if you really like it.
No, you do this.
I'm doing too. All right. Okay. All right. Example 10. Example 10. You go, oh, this is the exact same thing we did on the previous page, but with a slightly different picture. So we could do like top over bottom, 45 over 18 equals top over bottom, 52 over x. (52 times 18). Yeah, Ms. Lopez was saying that she would often combine yesterday's lesson and today's lesson, but I wanted to play bingo. So I separated them into 2 days. Yeah, you're welcome. And I'd say the bingo game was pretty fun, so.
Yeah, unless you lost.
I mean, not everyone can be a winner. That's what we learned in high school. All right, circle number 11, you're going to do that one. Today we're mostly doing a lot of cross multiplying and a lot of proportions. That's what we're doing a lot of today. I'm solving. Today's a relaxing day, turns out. All right, number 12. What should we do on number 12? And then what do we do? All right, and circle 13, you're going to do 13. Miss Rice, these are so fun. Thank goodness we're doing this today. I know, right? Okay, I'm going to take this opportunity to let you guys know that on Friday we are learning something. I know a lot of teachers are, or maybe, I don't know. I've heard a lot of students are not coming to school on Friday because they think we're not doing anything on Friday. We are. I am teaching on Friday. I'm just letting you know. Yeah. Yeah. So we had a whole week of school off. So I will be teaching on Friday. I'm just letting you know. I'm teaching on Friday. All right. Last one. 18 over 24. Okay, if I do 18 over 24, then what should I do for the other one? All right. Whew. So go ahead and finish up the problems on the notes, because they're not too bad. And then do the practice assignment. Done with all the notes and the practice assignment.
If you have any problem with math, call me. And then he's like,